At the operations center of a metropolitan traffic management department, a large digital map fills the wall. Dozens of intersections across the city appear as small nodes connected by lines representing roads. Each node changes color in a slow, rhythm green, yellow, red cycling through the same sequence over and over. For the engineers monitoring this system, the pattern is not just a visual signal. It represents a standardized procedure. Operating across an entire urban road network, every intersection follows the same fundamental order, allowing thousands of drivers to interpret traffic conditions instantly. Traffic lights do not function as isolated devices. Installed at individual intersections, they operate as part of a coordinated public infrastructure designed to regulate movement across complex transportation systems. Their predictable sequence green followed by yellow, then red forms a shared framework that drivers, pedestrians, and road planners rely on every day. Without this stability, urban traffic would quickly become uncertain and inefficient. The importance of this sequence becomes clearer when considering the environment in which traffic lights operate. In large cities, vehicles approach intersections continuously from multiple directions. Drivers must make rapid decisions while maintaining awareness of surrounding vehicles and pedestrians. Traffic signals therefore act as procedural communication. Each color represents a defined condition. Within a controlled system of movement, drivers approaching an intersection rely on the expectation that the signal will follow a familiar order, and pedestrians rely on the same expectation when crossing streets. This shared understanding did not appear automatically. It developed gradually as cities began confronting the challenges created by the rapid growth of automobile traffic in the early 20th century. Before standardized traffic lights existed, intersections were often controlled manually. Police officers frequently stood in the middle of busy crossings, directing vehicles with hand signals or whistles. Some cities experimented with mechanical signal devices mounted above the roadway that displayed commands such as stop or proceed. While these methods helped manage congestion temporarily, they lacked consistency. Different cities experimented with different signal systems, colors, and procedures. Drivers traveling between regions could encounter unfamiliar traffic controls that operated according to entirely different rules. As automobile travel expanded and road networks began connecting cities and suburbs into larger transportation systems, this lack of uniformity became increasingly problematic. Drivers needed to interpret signals quickly, even when entering unfamiliar areas. Municipal governments and transportation authorities gradually recognized that traffic control required common standards. Without predictable signal behavior, drivers could not form reliable expectations about how intersections would operate. Engineers and traffic safety organizations began studying accident patterns, traffic flow, and signal visibility to determine which signal arrangements produced the most predictable results. One of the earliest decisions involved selecting the colors used in signal displays. Several color combinations were tested, but certain choices proved more effective in real-world conditions. Red had already been widely used in railway signaling systems as a warning color, making it a natural choice to indicate stopping. Green became associated with permission to proceed. Between these two conditions, complete stop and unrestricted, movement engineers identified the need for an intermediate signal. Drivers approaching an intersection needed advance. Notice that the signal state was about to change. The yellow signal filled this role. Its purpose was not merely visual contrast, but procedural communication. It provided a short transition period during which drivers could safely prepare to stop before the signal turned red. Once these three signal states were established, transportation authorities faced another question. What order should they appear in? The sequence needed to minimize confusion and allow drivers to anticipate changes reliably. If signals changed unpredictably, drivers might hesitate or react abruptly, increasing the risk of collisions. Through observation and testing, engineers concluded that the most stable sequence was green, followed by yellow, followed by red. Green allowed vehicles to move through the intersection. Yellow indicated that the movement phase was ending. Red created a full stop condition that allowed traffic or pedestrians to proceed safely. This sequence formed a predictable cycle. that drivers could learn through repeated exposure. Over time, the pattern became embedded not only in traffic signals, but also in driver education programs, traffic laws, and roadway design practices. However, defining the color sequence alone was not enough. Traffic lights also required standardized hardware designs and operating procedures. Early traffic lights differed widely in appearance and operation. Some systems used only 2 signal lights, while others required manual control from nearby operator booths. As cities grew larger and traffic volumes increased, transportation departments began installing automated electrical signal systems, capable of cycling through signal phases without direct human control. These automated systems introduced the need for carefully defined timing intervals. The duration of each phase, green, yellow, and red, had to account for vehicle speed, intersection size, pedestrian crossing time, and driver reaction time. Traffic engineers developed standardized methods for calculating these intervals so that vehicles could clear intersections safely before opposing traffic received a green signal. Over time, these methods were documented in traffic engineering manuals and roadway design standards used by transportation agencies. These guidelines define the sequence of colors, the placement of signals, and the operational timing principles that ensured signals behaved consistently across entire road networks. As these standards spread, traffic lights across different cities began operating according to the same fundamental sequence. Drivers traveling between regions encountered signals that behaved in familiar ways, reinforcing the reliability of the system. This consistency became especially important as highways connected multiple cities and states into larger transportation networks. Even as traffic technology evolved, the basic signal sequence remained unchanged. Modern intersections often use computerized control systems capable of adjusting signal timing dynamically. In response to traffic conditions, signals can be synchronized along major corridors to improve traffic flow, and traffic management centers monitor thousands of intersections simultaneously. Yet the underlying order of green, yellow, and red continues to remain the same. The reason lies not in technical limitation, but in institutional stability. Millions of drivers have learned to interpret traffic signals according to this sequence, and transportation systems have been designed around it. Changing the order would introduce uncertainty into a system that depends on immediate recognition. Drivers approaching intersections must interpret signals instantly, without hesitation, because the existing sequence has been reinforced through decades of consistent use. It now functions almost automatically within everyday driving behavior. Today, traffic lights appear so familiar that their design rarely attracts attention. Yet each signal reflects decades of coordination between engineers, safety organizations, and public transportation authorities, working to standardize roadway movement. At intersections across cities and highways, the same cycle repeats continuously. Vehicles move during green, prepare to stop, during yellow, and pause during red before the process begins again. Within traffic management systems, engineers adjust timing patterns and coordinate signals across entire corridors. But the sequence itself remains constant. Its stability comes from long-term standardization, regulatory adoption, and repeated daily use across millions of intersections. As long as road networks depend on coordinated control of vehicle movement, the familiar sequence of green, yellow, and red will continue to function as one of the most stable procedural signals in modern public infrastructure.